Welcome to Paradise Valley Chalet. I'm John, and we're on a mission to teach cutting-edge technologies for a modern lifestyle. In this episode, we're installing Tesla electric vehicle chargers. We're also installing Clipper Creek pedestals and chargers. So, we just received delivery of 4 Tesla chargers. We're gonna go install them right now. And while there's nothing like the experience of driving a Tesla, today we're going to get our hands dirty and try to have some fun along the way while we install these chargers. Before we get into our install, I wanted to show you these pictures from a friend in the Tesla community. To me, they represent the true simplicity of charger installs. It's not expensive and it's not complicated. A typical charger install involves a breaker and landing 3 wires. In our installation, we're dealing with transformers, meters, panels, and chargers, with the goal of providing inspiration and ideas for your installs. Charging station number 1 has its own meter, a Tesla charger, and an RV pedestal for EV and RV charging. Charging station number 2 is right outside the front door of the chalet. It has a Tesla charger and a GFCI outlet. Charging station number 3 is powered from a sub-panel. It also has a Tesla charger and a GFCI outlet. Charging station number 4 has a Tesla charger and a Clipper Creek HCS50 electric vehicle charger. The HCS50 allows us to provide charging to nearly all non-Tesla EVs. And all the charging stations feature the ruggedized Clipper Creek Pro Mount Duo pedestals. As I said in the beginning, many basic charger installations are not going to require you to get super technical. But for higher demand situations, start with a load calculation that includes your EV chargers. Find your transformer, meter, and panel ratings. Then, you upgrade individual components as necessary. It all starts with the transformer. That's either going to be up on the pole or on the ground, like ours. Dealing with the central office of the electric utility can be somewhat political, depending on your jurisdiction. But if you need it, and you're lucky, they might help you out with a transformer upgrade. Or you can pay for one. After doing our load calculations and determining our transformer's capacity, we had our utility come and upgrade us to a 50 kVA transformer, giving us in the range of 600 amps plus. After the transformer comes the meter. This will need to be removed and replaced so that we can exploit the full power of our new transformer. So we've begun to uncover the conduit and lines from our old 200 amp meter, and we've begun to install the new 400 amp service. And until we're done with the next couple steps, we'll be running entirely on solar. Once we get the 400 installed and approved, the electric utility will come hook it up on their end. We got our design specs from the electric utility, which indicated the panels should be mounted on a piece of treated plywood between 2 4x6s. You can see our panel and supplies here. So we dug 3-foot holes, we'll plumb up the 4x6s, fill the holes with concrete, and once the concrete sets up, we'll mount the treated plywood and the panel on the 4x6s. So we successfully mounted the 400 amp panel. This is going to let us access 400 amps of the 600 amps from our transformer, and then ultimately branch out to our satellite locations across the property. So as we're preparing for the next phase of operations, we're also getting ready for the electric utility to come energize the service. Meters connected to the electric utility have 2 sides. One side is for the electric utility and the other side is for the property owner. So we'll first decommission our side, and then when the electric utility comes, they'll handle the decommissioning and then the hookup on their side. So next, on our side, we're going to cut this conduit, remove the wire, and decommission this meter. So we've cut it on this end. Now we'll head up to the chalet and demo the panel that's on the building. Before you work on any electric panel, you're going to want to know what it's connected to upstream and downstream. Now this appears to be a simple panel, but there is some complexity in the background. Here's our feed coming in from the meter we just decommissioned, and here's where those wires terminate. We'll have to disconnect all these in order to remove the conduit, the wire, and the panel. These existing circuits are connected to other parts of the Chalet's electrical system, like generator in and solar. So we'll take care to power down and disconnect the entire system while we demo this panel. So we disconnected everything and pulled the panel off the building. Once we manually uncover each end of the roughly 280-foot run of conduit and wire, we're going to remove the wire and leave the conduit in the ground. So we tie one end of the wire to a hitch and pull it out. We'll be able to reuse this wire on one of our chargers, and we kept it out of the landfill. Next, we're going to be doing trenching out to all our satellite locations. I like to go at least a foot deeper than what code calls for to make the trench more workable. So we trenched various runs across the 6-acre property. Here, we stopped the machine on both sides of our solar lines and we manually connected. Now we're ready to pull wire. So on our 400 amp panel, we've stubbed in 2.5-inch conduit. Let's go over the basics of working with conduit and wire. First, determine which panel you're starting in. And while there's no absolute rules covering every situation, generally, you're going to install a piece of conduit in that panel. Now these knockouts are stepped, so you can start with the smallest one and then work your way out till you get to the size that fits your conduit. Once you've got the correct size hole, you'll use the various pieces and bushings to assemble the conduit into the panel. Now when you're building conduit, you're going to be calculating and estimating all the parts and lengths in your run. So don't lock it down too tight until you're sure that everything fits. You'll then push your wire up through that conduit and into the panel. Once you get your first end in that panel, you'll then pull the other end through various conduit to your destination. One approach is to tie a rag to a string or a rope and suck it through the conduit with a shop vac. Now this also works on long distances, and it will establish a line from your source to your destination. Then you securely tape the rope to your bundled wire. It has to be secure enough to withstand the aggressive pulling that will enable it to get through the various twists and turns in your run. It can also help to add some lube to your bundled wire. And finally, one or more people push and one or more people pull. Once you get it all the way through on both sides, you can land your wires. And we used that method here. We stubbed in conduit to the 400 amp meter and pushed wire up into it. Now the utility is here to energize the 400 amp meter. They disconnected our old 200 amp meter. Now they'll run new conduit and new wire from the new transformer to the new 400 amp meter. And they'll be coming in on the left side of the panel. Now that we're energized, we're going to pull wire from the 400 amp meter to a new 200 amp panel on the building. Here, you see we made good progress pulling our wire through that 2.5-inch conduit, roughly 280 feet, to our destination. Once we're done pulling wire, we drop the entire run in our trench and fill it in. Next, we mount our 200 amp panel on the building. So we've got it mounted on the building and we've landed our wires. Now we're going to have a state inspection of our 200 amp panel and our 400 amp meter.
That's correct.
So he passed us here, but on the chargers, he misunderstood the technology. After consultation with Tesla, we provided him with the information he needed. Okay, let's head over to charging station number 3. Charging station number 3 is a sub panel with a 90 amp feed. Coming from our 200 amp panel on the building, we ran 246 aluminum wire to the sub panel. And from the sub panel, we ran our wires out to the charging station. We set our forms and run our conduit underneath the forms. That radius sweep is going to come up into the pedestal. Where the string lines intersect, we'll place our pedestal base 12 inches behind the curb and 18 inches to a side. Building the ProMount Duo is super easy. There's only 6 parts, 4 panels, a top, and the base. Once we drilled our holes with a hammer drill, we remove the debris from the holes and pound in our bolts. Once the bolts are secured, we use washers and nuts to secure the pedestal base to the concrete. We also placed washers underneath the pedestal base. This raises the pedestal base off the ground, thereby protecting it from water. And on a couple of the charging stations, we also used the washers to level the pedestal. With the base installed, we attach the two bottom panels of the ProMount Duo. We then run our wire from the electric panel up into the ProMount Duo. And with our appliances installed, we finish locking down the pedestal, and we're done with charging station number 3. This is our 200 amp meter. Now it's in addition to the 400 amp meter we installed earlier. So that's a total of 600 amps with 200 amps here. And that's feeding a 100 amp panel at charging station number 4. On charging station number 4, both the panel and the wire that we used are salvaged from our earlier work. We installed the 4x6, attached the panel to it, ran the wire from the meter to the panel, and landed our wires here. We then assemble the ProMount Duo, run our wires, and we'll start by installing the Tesla charger on this ProMount Duo. Coming from this 50 amp breaker, we're going out through 1.5 inch conduit and up into the pedestal. For extra safety, we also strip part of our ground wire and attach it to this lug on the ProMount Duo before running out to the Tesla charger. So we've got 3 wires. L1 stands for line, L2 stands for neutral, and then we have our ground. Once we tighten down all these wires, we'll then feed these pre-connected service wires into the main housing and land those as well. So once I'm done assembling the rest of the pieces, I'll land my wires. These are the 3 pre-connected service wires that we pulled through into the housing. We'll tighten them down according to the specs in the manual. Once all wiring has been secured, we set the dip switch settings. And remember, the rotary switch is variable. The setting that you choose is dependent on the electrical capacity you require and the size of the breaker you've installed. On this charging station, we're using a 50 amp breaker, so we set it to number 8. Once we're done, we reattach the ribbon cable and finish reassembling the charger. Once we're done locking it down, we power on the charger. And here, the LED lighting illuminates in a successful startup sequence. This Tesla charger is now ready for action, and we have the GFCI on the back. Now, with the versatility of the ProMount Duo, we could add other chargers or other electrical boxes as desired. And that's what we're going to do. We're going to install the Clipper Creek HCS50 on the back side of that ProMount Duo. The HCS50 is a 40 amp, 240 volt, 9.6 kilowatt charger. It has a NEMA 4 outdoor rated enclosure and a 25-foot charging cable. So we'll open up the top of the ProMount Duo, disassemble and move our GFCI outlet to the side. And this is actually the default suggested GFCI install location, so it's going to fit on there perfectly. We'll remove the top back panel, which will make it really easy to work with the wiring. So we got the panel off and we reassemble the GFCI outlet on the side. And we're going to have to pull some more wire for the HCS50. But luckily, when we installed the Tesla, we bundled in some extra wires which we can now use for pulling. So we've done a lot of work today, and development continues across the property here at the chalet. So we'll come back tomorrow and start fresh. Now we're going to run our wires for the Clipper Creek HCS50. We've got L1, L2, and a ground. We're going to be using the ground from the Tesla. Therefore, we'll only need to pull 2 wires. So first we bundle the 2 wires, and then we tape them to our pulling wire. Once it's all bundled up, we'll put some lube on it and pull it up through the ProMount Duo over to the panel. So I'll put the lube on it, make sure that it's clear of obstructions, and pull it through. While I'm pulling up into the panel, William is pushing. Once we get it into the panel, we'll strip our wires and land them in the breaker. So I'll secure the breaker in the panel and then trim my exposed wires before locking them down into the breaker. Since we only have one side installed, we're going to want to leave extra wire on both ends so that we can adjust our lengths as needed. This is the whip that comes pre-installed on the HCS50. We'll feed it into this pre-made hole on the ProMount Duo and lock it down. Next, we'll connect the ground of the whip up to a pigtail that lands on this lug and shares the Tesla ground. Next, we'll connect L1 and L2, locking everything down really tight. Once we've connected L1, L2, and our ground, we'll tape them all up. We've now completed the wiring from the 50 amp breaker in the panel, through the conduit, up into the pedestal, and to the HCS50. Next, we'll attach the HCS50 to the ProMount Duo with the included parts. We've attached the HCS50 to the ProMount Duo and we're ready to power it on. We've successfully powered on the HCS50, enabling us to provide high-powered charging to any EV that comes to our property. As well, we have the GFCI outlet and the Tesla charger, all on the ProMount Duo. We've completed the full install of charging station number 4. So let's head back over to the chalet and check out charging station number 2. Charging station number 2 is right outside the front door of the chalet. And you can see here on the chalet's main panel, we have a 50 amp breaker on the top left and a 20 amp breaker going out to the GFCI as well. And we run all those wires through conduit up into the ProMount Duo, and we've completed the installation of charging station number 2. Now let's head over to charging station number 1. So far, we've only used 400 amps of our 600 amp capacity, and we have an available 200 amps coming from the 400 amp meter. And we're going to repurpose the 200 amp meter that we removed in the beginning and use it as a sub-meter. So once we build the charging station, we repurpose the meter as a sub-meter by reconfiguring the wiring. We land our 2 hot wires and our ground on the back. We drill a hole and run our neutral through to the front. We install a neutral bar on the front and land our neutral wire on the installed neutral bar. We've now installed our 200 amp sub-meter with 100 amps going to the Tesla. This Tesla charger is currently using a 100 amp circuit, so we still have 100 amps free, and we're going to install an RV pedestal. Much like we demonstrated earlier, we'll cut our pieces and assemble our conduit and install the conduit into the panel, So we run our wire out of our meter and over to our direct burial RV pedestal. I'll strip my wires, treat them with Deox, and land them in the RV pedestal. We've completed the wiring. We now have 100 amps going to the Tesla and 100 amps going to the RV pedestal. Once we finish stabilizing the meter and the RV pedestal, we're ready to provide 90 amp Tesla charging. Charging for travel trailers and RVs via the RV pedestal. The RV pedestal, of course, can also be used to charge EVs with the NEMA 1450. That completes our install of charging station number 1. We hope you enjoy and found inspiration in our Tesla and EV charging installation video. Feel free to stop by for a charge, talk shop, and collaborate on the mission of our times.